family orbits its star with extraordinary proximity. TRAPPIST-1e, often called the Earth analog, resides comfortably in the system's habitable zone, where temperatures may permit liquid water to pool on its surface. Unlike our Sun, TRAPPIST-1 is a red dwarf, only 9% as massive and significantly cooler. This means that planets like TRAPPIST-1e, despite their tight orbits, receive just enough stellar energy to sustain potentially life-friendly environments without the scorching effects of proximity seen in our inner solar system. One of the most compelling aspects of TRAPPIST-1e is its potential to host a stable, Earth-like atmosphere. Researchers have leveraged advanced tools like the James Webb Space Telescope, JWST, to search for biosignatures, gases like oxygen, methane, or carbon dioxide, which might hint at biological activity. Initial studies suggest that TRAPPIST-1e likely possesses a rocky composition with a density strikingly similar to Earth's, increasing the odds that it retains an atmosphere conducive to life. The planet's surface is another topic of intrigue. TRAPPIST-1e likely exhibits tidal locking, with one hemisphere perpetually facing its star while the other remains in darkness. This unique feature creates stark temperature contrasts but may also foster complex weather systems. The planet's terminator line, where day meets night, could serve as a temperate sweet spot for habitability. Water is the cornerstone of life as we know it, and TRAPPIST-1e holds promise in this regard. The habitable zone placement implies that, under the right atmospheric conditions, liquid water could exist on its surface. Spectroscopic analyses conducted with the JWST aim to detect water vapor signatures, which would dramatically enhance the planet's appeal as a life-friendly world. The possibility of subsurface oceans, similar to those on Europa or Enceladus in our own solar system, cannot be ruled out. If TRAPPIST-1e harbors underground water reservoirs, they may be shielded from stellar radiation, offering a haven for microbial life. Researchers are also investigating whether volcanic activity or hydrothermal vents could provide the necessary energy to sustain life forms. Despite its many alluring qualities, TRAPPIST-1e faces challenges common to planets orbiting red dwarf stars. Stellar flares and intense radiation bursts from TRAPPIST-1 could strip away planetary atmospheres over time. However, if TRAPPIST-1e's magnetic field is robust, it might shield the planet from these destructive forces, preserving its atmosphere and habitability. Moreover, the long lifespans of red dwarf stars offer an advantage. While our Sun has a lifespan of roughly 10 billion years, red dwarfs like TRAPPIST-1 can burn for trillions of years. This extended stability provides ample time for life to emerge and evolve, assuming other conditions are met. The exploration of TRAPPIST-1e and its sister planets represents a cornerstone of modern exoplanetary science. Missions like the JWST and future observatories, such as the Extremely Large Telescope, ELT, are poised to unlock the secrets of this extraordinary system. By analyzing starlight as it passes through TRAPPIST-1e's atmosphere, scientists hope to identify chemical fingerprints that could point to biological activity. In addition to remote observations, visionary proposals for interstellar probes could one day bring humanity closer to TRAPPIST-1e. Concepts like Breakthrough Starshot aim to propel spacecraft to nearby star systems within a few decades. While such missions remain in their infancy, they highlight the growing ambition to directly study worlds like TRAPPIST-1e. The quest to understand whether we are alone in the universe hinges on planets like TRAPPIST-1e. As an Earth-like world in a relatively nearby system, it provides an unparalleled opportunity to test hypotheses about life's universality. If signs of life are detected, it would revolutionize our understanding of biology and the cosmos. Conversely, if TRAPPIST-1e proves lifeless despite its favorable conditions, it may underscore the uniqueness of Earth's biosphere. Such findings would carry profound philosophical and scientific implications, reshaping our perspective on the fragility and rarity of life. This enigmatic exoplanet, often referred to as the Second Earth, stands as a beacon of possibility in the vastness of space. Orbiting its dim star within the habitable zone, the world, sometimes called the Twilight Planet due to its tidally locked nature, beckons scientists with its tantalizing promise of alien environments. The study of this celestial neighbor has revealed a planet that defies simple categorization, blending characteristics of terrestrial worlds with the unique challenges posed by its extreme proximity to a red dwarf. The shadowed half of this distant globe, bathed in perpetual night, may hold vast reserves of frozen water, locked away beneath icy crusts. Meanwhile, the sunlit hemisphere endures the unyielding radiation of its faint but volatile parent star. Yet, it is the terminator region, a thin band where light and darkness meet, that has captured the imagination of astrobiologists. Here, conditions may be just right for the formation of liquid water, a critical ingredient for the emergence of life. This so-called golden crescent represents a fascinating test case for planetary habitability beyond Earth. The star system, hosting this extraordinary sphere of rock and possibility, challenges our understanding of planetary formation and survival. In contrast to our solar system, where gas giants like Jupiter act as shields against incoming debris, the worlds orbiting this red dwarf lack such massive protectors. And yet, the exoplanet of Twilight appears remarkably stable, defying expectations of chaotic bombardment. This stability raises questions about the early history of its formation and the role of interstellar forces in shaping its destiny. Further study of this stellar sibling has revealed its remarkable density, suggesting a planet rich in heavy metals and silicates. Such a composition hints at a geologically active surface, potentially marked by volcanic activity or tectonic shifts. If so, these processes could play a pivotal role in recycling carbon dioxide and other greenhouse gases, creating a self-regulating climate system akin to Earth's. Alternatively, the lack of plate tectonics might result in a static environment, where ancient surface features endure for billions of years. Exploration of this exo-Earth has sparked debates about the role of magnetospheres in sustaining habitability. On our home planet, Earth's magnetic field shields us from harmful solar winds and cosmic radiation, preserving the atmosphere and enabling life to thrive. Scientists hypothesize that this alien world may possess a similar magnetic shield, generated by a molten iron core. If true, it would bolster hopes for the long-term stability of its climate and atmospheric composition. Without such a shield, however, the relentless stellar flares from its red dwarf star could strip away any protective gases, rendering the eternal dusk planet a barren, airless wasteland. The possibility of microbial life on this rocky orb ignites fierce curiosity. Could extremophiles, microorganisms capable of thriving in extreme conditions, find a foothold in the planet's more temperate regions? If so, they might exist in forms entirely alien to us, adapting to a world of stark contrasts and perpetual extremes. The discovery of even the simplest life forms here would profoundly alter our understanding of biology and the adaptability of living systems. Astronomers continue to refine their models of the Earth analog, using state-of-the-art telescopes to analyze its atmospheric composition. With the advent of instruments like the James Webb Space Telescope, scientists hope to detect biosignatures, subtle chemical imprints of life. The presence of gases such as oxygen, methane, or ozone in its atmosphere would be a groundbreaking discovery, pointing to the possibility of biological activity. Conversely, a barren atmosphere dominated by carbon dioxide or nitrogen could imply a lifeless world, reminding us of the fragility of life in the cosmos. This alien cousin of Earth also serves as a proving ground for interstellar exploration. While current technology limits us to remote observations, visionary projects like Breakthrough Starshot hint at a future where humanity might send robotic emissaries to nearby star systems. Tiny spacecraft propelled by powerful lasers could reach this distant world within decades, transmitting high-resolution data back to Earth. Such missions would mark the dawn of interstellar exploration, transforming the distant neighbor from a point of light in the night sky to a well-documented world. The cultural implications of the shadowed twin extend beyond science. Its discovery has inspired artists, writers, and dreamers to reimagine humanity's place in the universe. Depictions of its rugged landscapes, illuminated by the eerie glow of its red dwarf star, evoke a sense of wonder and longing. Could this distant planet serve as a refuge for future generations? Or is it a reminder of the uniqueness of Earth, a fragile oasis in an otherwise inhospitable cosmos? The mysteries of this stellar counterpart remain vast, and each new observation adds a piece to the puzzle. Researchers are particularly intrigued by the possibility of organic molecules forming on its surface or in its atmosphere. Such compounds, the building blocks of life, could provide crucial insights into prebiotic chemistry and the conditions necessary for life to emerge. If the pale wanderer proves hospitable to even the simplest organisms, it would redefine the boundaries of habitability and expand our understanding of life's potential in the universe. As technology advances, the study of this exosibling continues to evolve. Missions planned for the coming decades will employ advanced spectrometers, capable of analyzing the light reflected and absorbed by its surface. These observations will help determine the composition of its soil, the presence of minerals, and even the likelihood of liquid water. With each new discovery, the rocky enigma becomes less of a distant dream and more of a tangible reality, drawing us closer to answering the age-old question, are we alone? The cosmic twin of Earth continues to captivate scientists with its intricate dance around its dim star. Orbiting at a distance that perfectly balances energy and temperature, this exoplanet, often described as the Crimson Haven, embodies the delicate equilibrium necessary for life. Its close orbit around its red dwarf sun exposes it to a slow, rhythmic stellar cycle that profoundly impacts its climate and atmospheric dynamics. The perpetual day side of this tidal orb basks in the steady but subdued glow of its parent star, creating a stark contrast to the frigid night side. The boundary between these extremes, the twilight zone, could act as a crucible for complex atmospheric circulation. Winds might carry heat from the illuminated hemisphere to the frozen regions, creating conditions for water to exist in liquid form at the planet's surface or even beneath its crust. Advanced climate modeling has revealed fascinating possibilities: polar ice caps extending into the night side, massive cloud formations on the day side, and constant storms in the transition zones. This eternal twilight planet poses questions that reach beyond habitability into the realms of planetary evolution. The tidal locking it experiences is not unique, many exoplanets close to their stars share this characteristic. Yet, TRAPPIST-1e, or the dusklit world, stands apart for its ability to potentially sustain life despite this constraint. The energy balance between the hemispheres could be moderated by atmospheric composition, with greenhouse gases like carbon dioxide or methane acting as insulators. If these gases are present in just the right proportions, the planet could maintain a stable climate over millions of years. In recent studies, astronomers have focused on the possibility of a dense, oxygen-rich atmosphere on this starlight sibling. While oxygen is often associated with biological processes, it could also result from abiotic mechanisms, such as the photodissociation of water molecules under intense stellar radiation. The existence of oxygen without accompanying methane or other biosignatures would complicate the search for life, challenging scientists to distinguish between chemical processes that mimic biological activity and those that genuinely signal life's presence. The planetary surface of this cosmic mystery is equally intriguing. If volcanic activity is ongoing, it could contribute to the replenishment of atmospheric gases while creating geothermal pockets of habitability. Hydrothermal vents, similar to those found in Earth's oceans, could provide energy sources for microbial ecosystems. These vent systems, shielded from the harsh radiation of the star, might host unique life forms that thrive in extreme environments. The very thought of alien microbes surviving under such conditions fuels the search for similar systems on other rocky worlds across the galaxy. The shadowed Earth, as some researchers call it, also offers an unparalleled opportunity to study the long-term effects of stellar radiation on planetary atmospheres. Red dwarfs, while long-lived, are notorious for their flaring activity. During these solar events, bursts of charged particles could erode a planet's atmosphere over time. Yet, TRAPPIST-1 appears to defy this trend, possibly due to a strong magnetic field generated by a liquid metallic core. This protective barrier could act as a shield, preserving the planet's habitability even in the face of constant stellar bombardment. For scientists, the alien mirror serves as a reminder of how interconnected planetary systems are. The interplay between its surface, atmosphere, and magnetic field mirrors the dynamics observed on Earth, albeit under vastly different conditions. This makes the extraterrestrial twin an ideal testbed for developing and refining models of planetary evolution, habitability, and climate science. Each observation adds a new layer of complexity to our understanding, challenging existing theories and inspiring innovative approaches. The future of research into this habitable paradox lies in the hands of next-generation observatories. The James Webb Space Telescope has already begun unlocking the secrets of its atmosphere, but even more powerful instruments, such as the upcoming LUVOIR, large UV/optical/IR surveyor, promise to take the search for life to unprecedented levels. These telescopes will analyze the starlight passing through the exoplanet's atmosphere during transits, identifying chemical signatures that could point to biological activity. With each new dataset, the reddish pearl transforms from an abstract concept into a tangible world rich with scientific potential. The allure of this distant sibling extends beyond the scientific community. For philosophers, its existence forces humanity to grapple with existential questions about our place in the universe. If the Crimson Echo harbors life, it would mean that the processes leading to biology are not unique to Earth but are a natural outcome of planetary evolution under the right conditions. Conversely, if the planet is barren despite its promising characteristics, it might underscore the rarity and fragility of life as we know it. Explorers and engineers dream of the day when humanity might send robotic emissaries, or even crewed missions, to this stellar cousin. The development of advanced propulsion systems, capable of reaching nearby star systems within a human lifetime, remains a long-term goal. Concepts like fusion-powered spacecraft or laser sails could turn the dream of visiting this rocky enigma into reality. Until then, scientists must rely on remote sensing and theoretical models to decode its mysteries. This twilight orb stands as a beacon of hope and wonder in the vastness of space. Each new discovery brings humanity closer to understanding the conditions necessary for life, not just on TRAPPIST-1 but throughout the cosmos. The study of this remarkable exoplanet serves as a bridge between science and imagination, inspiring future generations to look up at the night sky and dream of worlds yet unseen. This distant wonder, often dubbed the alien Eden, continues to redefine humanity's understanding of what it means to be habitable. Orbiting its ancient red dwarf star with such precision, the exoplanet dances in a gravitational harmony that defies the chaotic beginnings of its system. While TRAPPIST-1e and its sister planets exist in extreme proximity to their Sun, the stability of their orbits over billions of years suggests that these worlds may have weathered the violent youth of their star, an achievement that lends further credence to the possibility of their survival as bastions of habitability. Scientists hypothesize that the planet's slow rotation, locked into tidal equilibrium, creates dynamic and turbulent atmospheric conditions. The ever-present heat on its day side may generate rising currents of air that travel toward the cold night side, cooling and condensing into massive, sprawling cloud systems. These clouds, in turn, reflect some of the incoming radiation from the red dwarf star, preventing runaway heating. Meanwhile, the frigid night side might act as a heat sink, fostering a bizarre, planet-wide exchange of energy that may sustain a globally balanced climate. The twilight frontier, as some researchers call it, is where life could flourish. This narrow, crescent-shaped region is bathed in soft, eternal dusk, with temperatures potentially hovering near Earth-like levels. Here, liquid water could exist on the surface, forming rivers, lakes, or even shallow seas. If this ribbon of twilight hosts an atmosphere thick enough to distribute warmth evenly, it might serve as an ecological oasis, teeming with microbial life forms that thrive in the delicate balance between light and dark. The geological activity of this shadowed gem remains one of the most compelling areas of research. Recent models suggest that internal heating, caused by tidal interactions with neighboring planets, could drive volcanic eruptions or even tectonic movement. Such activity would play a crucial role in maintaining the planet's atmosphere, replenishing it with vital gases while creating diverse habitats for potential life. Volcanism might also release water vapor, which, if it condenses into rain, could carve intricate landscapes of valleys and deltas, painting the surface with geological features that mirror Earth's dynamic history. As this exoplanetary sibling continues to be studied, the question of its magnetic field has become a focal point. A robust magnetic field would not only shield the planet from harmful radiation but also preserve its atmosphere against the powerful stellar winds of its red dwarf host. Without such a protective field, the planet's surface could be exposed to intense bursts of radiation during stellar flares, dramatically reducing its chances of sustaining life. Yet, even in this scenario, life might adapt by retreating underground or beneath protective layers of ice. The cosmic mirror holds a particular fascination for astrobiologists, who view it as a laboratory for testing theories about the universality of life. If the planet contains liquid water and the right chemical building blocks, life could have emerged independently, following paths this alien sanctuary, often referred to as the stellar twin, continues to captivate the scientific imagination. Orbiting its faint red star in a delicate gravitational balance, this remarkable world stands as a testament to the possibilities of life beyond our solar system. The Crimson Voyager, with its potential for hosting Earth-like conditions, challenges our understanding of planetary resilience and adaptability in extreme environments. The exocousin of Earth, locked in eternal rotation with one side facing perpetual light and the other eternal darkness, creates a unique dynamic of contrasts. Its day side, bathed in the soft red glow of its star, could be a land of scorching heat and towering clouds. The night side, frozen and silent, might be home to ice sheets or subsurface water reservoirs. Between these extremes lies the habitable band, a narrow twilight region where temperatures and conditions could align perfectly for the presence of liquid water, a prerequisite for life as we know it. The rocky wanderer, much like Earth, shows evidence of being composed largely of silicate materials and heavy elements. These properties suggest that it could harbor a solid surface, one potentially marked by a diverse landscape of plains, mountains, and perhaps ancient volcanic remnants. Scientists speculate that geothermal activity beneath the crust of this stellar sibling could create energy sources similar to Earth's hydrothermal vents, which are known to support thriving ecosystems deep in our oceans. One of the most intriguing possibilities for the shadowed orb is its atmosphere. Preliminary studies suggest the potential for a thick layer of gases that could act as a buffer against the star's radiation. If such an atmosphere exists, it might contain water vapor, carbon dioxide, and other compounds that not only sustain a stable climate but also provide essential ingredients for life. The presence of biosignatures, such as oxygen or methane, would transform the extraterrestrial Eden from a scientific curiosity into a revolutionary discovery. The twilight gem is not without its challenges. Its proximity to a red dwarf star subjects it to frequent stellar flares, which could strip away its atmosphere if unprotected. However, the existence of a magnetic field could mitigate these effects, shielding the celestial neighbor from harmful solar winds and maintaining its atmospheric integrity. This protective feature, if confirmed, would greatly enhance the planet's potential to host life, making it one of the most promising candidates in the search for habitable worlds. The dusklit enigma has also reignited discussions about interstellar exploration. Advanced telescopes like the James Webb Space Telescope are already unlocking new details about its atmospheric composition, but the dream of visiting this distant world remains alive. Concepts such as laser-propelled probes or fusion-powered spacecraft aim to bring humanity closer to the cosmic frontier, allowing us to directly study its surface and perhaps even sample its environment for signs of life. The pale Voyager is more than a distant dot of light in the sky, it represents the hopes and dreams of a species yearning to understand its place in the cosmos. Whether it is teeming with microbial ecosystems or a barren rock, the discoveries awaiting on this stellar kin will undoubtedly reshape our perspective on life's potential across the galaxy. This crimson refuge, orbiting its faint, ancient star, remains one of the most captivating enigmas of modern astronomy. Often called the exoplanetary sibling, it represents an extraordinary opportunity to explore the boundaries of planetary habitability. Nestled within its host star's habitable zone, the eternal twilight sphere offers a tantalizing glimpse into what might be a second home for life in the universe. The distant cousin of Earth exhibits a range of extraordinary features. Its tightly locked orbit creates a permanent divide between the searing day side and the frigid night side, forming a stark dichotomy across its surface. The transition zone between these extremes, often referred to as the life belt, may hold the key to understanding how life could adapt to such unique conditions. Here, temperatures are believed to hover at levels conducive to liquid water, the fundamental ingredient for life as we know it. The celestial wanderer has inspired countless theories about its atmospheric composition. Researchers hypothesize that this reddish sibling might host a thick layer of gases that moderates the temperature contrasts between its hemispheres. This atmosphere could act as a natural thermal blanket, circulating heat and creating a relatively stable environment in the twilight regions. Advanced spectroscopic studies are already underway to detect key atmospheric components such as water vapor, carbon dioxide, and oxygen, each of which could provide vital clues about the planet's habitability. The star-bound neighbor has also raised intriguing possibilities about its hydrological systems. If liquid water exists, it may form narrow rivers or shallow oceans along the planet's terminator line. Alternatively, water might be locked away as ice on the night side, periodically released through geothermal activity or subsurface heating. This shadowed oasis could serve as a breeding ground for extremophile-like organisms, adapted to thrive in conditions far harsher than those on Earth. Geological activity on the alien sibling is another avenue of intense exploration. Internal heating from tidal interactions with its neighboring planets in the TRAPPIST-1 system might drive volcanism and tectonic activity, creating a dynamic and ever-changing surface. These processes could replenish atmospheric gases and maintain long-term climate stability, critical for sustaining life. Furthermore, volcanic regions on this exotwin might host geothermal hotspots, fostering the kinds of ecosystems seen around Earth's hydrothermal vents, places where life thrives in complete isolation from sunlight. The tidally locked mystery also challenges scientists with the unique effects of its host star's red dwarf nature. These stars are known for their volatility, emitting powerful stellar flares that could erode a planet's atmosphere over time. Yet the Crimson Enigma appears to have defied this fate, likely due to its potential magnetic field. If this shield exists, it would be a vital factor in protecting the planet's atmosphere and preserving the conditions necessary for life. The dusklit pearl also represents a critical milestone for interstellar exploration. Observations of this world are paving the way for more advanced missions and instruments capable of probing its secrets in unprecedented detail. Future telescopes, such as the Extremely Large Telescope, ELT, and LUVOIR, aim to unlock even more insights into its composition, climate, and potential biosignatures. Meanwhile, visionary projects like Breakthrough Starshot dream of one day sending probes to the stellar cousin, capturing images and data from its surface within a human lifetime. The Twilight Orb, while still shrouded in mystery, serves as a reminder of the vast possibilities that lie beyond our solar system. Its discovery has reignited humanity's fascination with the cosmos, inspiring a new generation of explorers, scientists, and dreamers to imagine what life might look like on a world so similar yet so alien to our own. If this far-off Earth analog harbors life, it could provide answers to one of the greatest questions of all: are we alone in the universe? Even if the shadowed world proves barren, its study will teach us invaluable lessons about planetary evolution, climate dynamics, and the resilience of worlds orbiting volatile red dwarf stars. Each observation and model refines our understanding, bringing us closer to uncovering the truths hidden within the light of its distant star. The exoplanetary marvel challenges not just our scientific knowledge but also our philosophical perspectives. If it hosts life, it will reveal that biology is not unique to Earth but an intrinsic part of the universe. If it does not, it will remind us of the rarity and preciousness of our fragile blue world. Either way, the alien mirror has become an irreplaceable part of humanity's search for meaning among the stars. The crimson reflection, as some call it, is not merely an object of study, it has become a symbol of the unyielding human drive to understand the cosmos. TRAPPIST-1e, this stellar anomaly, exists as a puzzle piece in the broader tapestry of exoplanetary science, and every observation draws us closer to unraveling its secrets. Its allure lies not only in its potential to host life but in the profound questions it raises about the diversity of planetary systems and their capacity to nurture biology. The Twilight Voyager, locked in a gravitational embrace with its dim parent star, may hold answers about the adaptability of life under conditions vastly different from those on Earth. While the harsh radiation from its volatile red dwarf might seem hostile to life, some researchers argue that such conditions could drive evolution in unexpected ways. Lifeforms, if they exist on this distant echo of Earth, might have developed biochemical pathways to shield themselves from ultraviolet radiation or utilize the dim, reddish light for energy in ways we have yet to imagine. Atmospheric studies of the celestial sibling have revealed intriguing possibilities. If clouds of reflective particles exist on its day side, they could scatter incoming stellar radiation, preventing the planet from overheating. Conversely, a thicker atmosphere on the night side could act as insulation, trapping heat and maintaining a stable temperature gradient. This balance, if present, might create microclimates where complex ecosystems could thrive. The Terminator line, a perpetual band of twilight, represents the most likely candidate for such regions, a place where liquid water could pool and nutrients might circulate. Beyond its physical characteristics, the exo-Earth also offers an unparalleled opportunity to refine our methods for detecting life on distant worlds. Current efforts to analyze its atmosphere using the James Webb Space Telescope have focused on identifying specific molecules like oxygen, ozone, methane, and water vapor. The detection of these gases in the right proportions would strongly suggest biological processes. However, even the absence of such biosignatures could be valuable, pushing scientists to re-evaluate what habitable truly means in the context of alien worlds. The reddish twin also serves as a natural experiment in planetary geology. Its rocky composition, combined with the intense gravitational interactions of its neighboring planets, suggests a dynamic interior. These tidal forces may generate enough internal heat to sustain volcanic activity, which could in turn support a cycling of elements between the surface and the atmosphere. Such activity, crucial for maintaining habitability over long timescales, might also create striking geological features, towering volcanoes, expansive lava plains, or deep fissures carved by tectonic shifts. The tidally bound sphere is not alone in its system, and the interplay between it and its neighboring planets offers valuable insights into multiplanetary systems. The TRAPPIST-1 system, with its 7 tightly packed worlds, is a rare opportunity to study how planetary environments evolve in close proximity to one another. The gravitational tug-of-war among these planets creates orbital resonances that stabilize their orbits, a phenomenon that might also influence their climates and potential habitability. This symphony of worlds is a cosmic dance that has persisted for billions of years, a testament to the delicate balances that nature can achieve. As humanity's technological capabilities grow, so too does the ambition to explore the alien sanctuary in greater detail. Future telescopes, both space-based and ground-based, will provide unprecedented resolution, allowing scientists to map surface features, track atmospheric changes, and perhaps even detect signs of vegetation or other large-scale biological processes. Missions like LUVOIR or HABEX could one day capture direct images of this cosmic counterpart, revealing it as more than just a point of light, a fully realized world with its own landscapes and weather systems. The twilight orb is also a source of inspiration for interstellar exploration. Concepts for reaching nearby star systems, such as Breakthrough Starshot's laser-driven probes, are already in development. These microspacecraft, capable of traveling at a significant fraction of the speed of light, could reach the TRAPPIST-1 system within a few decades, providing humanity with its first close-up view of an exoplanetary system. Such missions, though still in their infancy, highlight the growing convergence of science and engineering in the quest to explore the stars. The cultural impact of the stellar twin cannot be overstated. Its discovery has sparked a renaissance of creativity, inspiring art, literature, and philosophy that explore the implications of finding another Earth-like world. For some, the dusk-lit marvel represents hope, a vision of humanity's future among the stars. For others, it serves as a humbling reminder of Earth's uniqueness and the fragility of life in an often hostile universe. The study of this distant neighbor has profound implications for our understanding of life's potential in the cosmos. If life is found on this crimson refuge, it will confirm that biology is not a cosmic anomaly but a natural outcome of the universe's processes. If no signs of life are detected, it will sharpen our focus on the conditions that make Earth so uniquely suited for life. In either case, the exo-Earth stands as a symbol of humanity's relentless curiosity and determination to seek answers to the most profound questions. The exploration of this cosmic enigma is far from over. As each new instrument and mission brings us closer to unraveling its mysteries, the alien cousin will continue to inspire awe, challenge assumptions, and expand the boundaries of human knowledge. It is not merely a planet, it is a gateway to understanding our place in the universe and the possibilities that lie beyond. The stellar echo reminds us that the cosmos is vast, filled with worlds waiting to be explored, each one holding the potential to transform our understanding of existence itself. The crimson outlier, still shrouded in mystery, remains a focal point of scientific intrigue and speculation. Every detail we uncover about this remarkable world strengthens its position as a prime candidate for hosting life. Its placement within the habitable zone of its dim red star, a region often referred to as the Goldilocks zone, is only the beginning of the story. The stellar parallel offers far more than just favorable temperatures, it provides a glimpse into how life might emerge and evolve under entirely different cosmic circumstances. The eternal twilight sphere, with its tidally locked orbit, poses unique challenges for habitability. Unlike Earth, where the rotation creates dynamic day-night cycles, this alien world experiences an unchanging dichotomy. The day side, constantly bathed in the faint red glow of its star, might develop thick, heat-reflecting cloud layers to moderate surface temperatures. The night side, in perpetual darkness, could accumulate vast ice sheets, creating a frozen realm that contrasts starkly with the scorching heat of the day. Between these extremes, the life band, the narrow zone of perpetual dusk, offers a promising sanctuary where temperatures may remain mild enough to sustain liquid water. The possibility of water, either on the surface or locked within subsurface reservoirs, is central to the planet's allure. If liquid water exists, it could flow through the twilight zone in narrow rivers or pool into shallow lakes, creating environments rich in the potential for microbial life. The reddish twin may also harbor vast oceans beneath a thick ice crust on its dark side, similar to Europa or Enceladus in our solar system. Such subsurface oceans, warmed by geothermal activity, could provide a stable and long-lasting refuge for life, protected from the harsh radiation of its volatile red dwarf star. Astrobiologists studying the exo-Earth are particularly interested in its atmospheric composition. If the atmosphere contains greenhouse gases like carbon dioxide, methane, or even water vapor, it could trap heat efficiently, smoothing out the extreme temperature differences across the planet. Additionally, the presence of oxygen, though not necessarily a direct indicator of life, would suggest intriguing chemical processes at work. Future observations using advanced telescopes aim to probe deeper into these possibilities, searching for the subtle chemical fingerprints that might reveal whether this alien haven harbors life. The shadowed cousin also raises questions about planetary geology. Its density composition, with a core rich in heavy metals and a crust capable of sustaining tectonic activity. Volcanism on the planet's surface could play a key role in recycling essential elements and releasing gases into the atmosphere, a process that might sustain a stable climate over millions of years. If hydrothermal vents exist beneath its surface, they could energy sources, fostering unique ecosystems similar to those found in Earth's deep oceans. The eject effect, it is vast worlds, all tightly packed around their interact gravitationally in a delicate orbital resonance. This planetary symphony stabilizes their orbits, influence their climates and geological activity. The interactions among these worlds offer a rare opportunity to study the dynamics of compact planetary systems, shedding light on how such configurations exist over billions of years. One as a mere apparent stability. Red dwarfs, though long-lived, are known for their volatile behavior, emitting powerful flares that could strip away planetary atmospheres over time. However, February appears to defy this threat, potentially protected by a magnetic field that shields it from stellar radiation. If this is the case, it would mark a significant milestone in our understanding of how planets in such extreme environments can sustain life-friendly conditions. The tidal enigma has also become a testbed for cutting-edge technologies designed to explore distant worlds. Instruments like the James Webb Space Telescope are already providing unprecedented insights into its atmosphere. Observatories, such as the Habitable Worlds Observatory, promise even greater discoveries. These tools are capable of detecting faint signals to the presence of life, such as variations in atmospheric composition over time or even seasonal changes indicative of biases. The EXO fuels humanity's aspirations for interstellar exploration. It's like Breakthrough Starshot envisions sending tiny, high-speed probes to nearby star systems, including the TRAPPIST system, to capture close-up. Such missions, while decades away, represent the next great leap in humanity's quest to reach out into the cosmos. The Twilight Voyager stands as a symbol of what might be achievable, a distant goal that inspires engineers, scientists, and dreamers alike. Philosophically, the alien echo forces us to confront profound questions about our place in the universe. If life exists on this, it would confirm that the processes of biology are not unique to Earth, but a natural outcome of the cosmos. Such a discovery would reshape not only but also humanity's sense of identity, proving that we are part of a life's legacy. On the other hand, if the shadowed wonder proves barren, it would highlight the extraordinary of this crimson frontier. Each new observation peels back another, revealing a world that is at once familiar and alien. Whether it ultimately proves to be a cradle of life or a barren rock, the stellar cousin will forever remain a testament to humanity's insatiable curiosity and our enduring desire to understand the universe. This cosmic sibling, with its quiet orbit around a faint, ancient star, reminds us that even in the vast emptiness there are places where life might yet bloom. Discovered. The ray continues to drive humanity's greatest questions about life and the universe. As scientists push the boundaries of technology and theory, the mysteries of this exo-Earth become clearer, yet simultaneously deeper. This alien world, orbiting quiet compact planetary system, a laboratory for exploring everything from planetary geology to astrobiology to dynamics. The dusk-lit enigma is no longer just a point of light in the sky, it is a gateway to life's potential across the cosmos. The tidal marvel, locked in gravitational stasis with one side eternally basking in light and the other forever in shadow, likely harbors an extraordinary range of environments. The Terminator Zone, where day meets night, remains the prime focus of habitability studies. This narrow band of twilight could harbor mild temperatures, liquid water, and even active weather systems. Tide may carry heat and moisture, into the cooler regions, creating a cycle of precipitation and evaporation that sustains complex ecosystems, if life exists. However, the Crimson Twin does not make survival easy. The red dwarf star it orbits emits frequent solar flares, bursts that could wreak havoc on the Earth. But this stellar echo might have a natural defense, a magnetic field. Generated by a molten core deep within its interior could act as a shield, protecting its atmosphere from being stripped away and allowing it to sustain a stable climate over. Such a magnetic field opened the door to possibilities for life on the surface, as it could block harmful cosmic rays while allowing essential light and heat to reach the planet. The shadowed oasis is not just a scientific curiosity, it is also a place of profound geological interest. Its density and composition suggest a rocky world, yet unique in its formation and evolution. Gravitational interactions with its neighboring planets in the TRAPPIST generate tidal heating, which may drive volcanic activity beneath its surface. These volcanic processes could release gases like carbon dioxide, replenishing the atmosphere and creating localized hotspots where life might flourish. If tectonic activity exists, it could further diversify the planet's swarming mountains, valleys, and deep ocean basins that are reservoirs for liquid water. The exosibling also challenges scientists to assumptions about habitability. While Earth-like conditions are often seen as the gold standard, the Twilight Refuge may demonstrate that life can arise and thrive under entirely different circumstances. In its dim, reddish environment, life relies on alternative biochemical processes, perhaps utilizing the faint infrared light from its star as an energy source. Microbial life, if present, could be adapted to extreme radiation, high levels of carbon dioxide, and long periods of environmental stability punctuated by bursts of activity during stellar flares. One of the most exciting aspects of the alien haven is its potential to host water in multiple forms. While liquid water on the surface remains the holy grail of astrobiology, the possibility of vast underground oceans is equally intriguing. Subsurface water could remain liquid due to geothermal heating, creating a stable, long-term habitat for life. If this cosmic cradle hosts hydrothermal vents, it might mirror the conditions thought to have given rise to life on Earth. A glimpse could be universe. This enigma is also a proving ground. Instruments like the James Telescope are already revolutionizing to study distant worlds, providing detailed analyses of their atmospheres and surface conditions. Spectroscopic observations of this stellar twin have begun to reveal its atmospheric structure, with the hope of detecting biosignatures such as oxygen, methane, or even ozone. Future missions, like the LUVOIR or HOPES, will be capable of the planet, potentially capturing the first clear view of an Earth-like world beyond our solar system. The Twilight Voyager inspires not only scientists but also engineers and futurists. Steps for interstellar travel, such as laser-driven light sails or fusion-powered spacecraft, are being developed with planets like this in mind. A probe sent to the TRAPPIST-1 system could provide humanity with data on an exoplanet, revolutionizing of the universe. Mission centuries away, represent the next generation, and the crim serves as a shining beacon for what might one day be achievable. Culturally, the distant cousin has sparked a renaissance in art, literature, and philosophy. Its discovery has inspired countless works of fiction, imagining what life might look like on a tidally locked world, rises or sets. Philosophers have pondered the implications of finding life, or not finding it, on such a world. Would it prove that life is common, or would it remind us of how uniquely precious Earth is? Either way, the alien mirror forces humanity to reflect on its place in the cosmos, encouraging a broader perspective on the fragility and resilience of life. The exotwin, whether teeming with microbial life or barren, offers profound lessons about the nature of existence. If life is found on this stellar echo, it would suggest that biology is a phenomenon, a condition. Conversely, if lifeless despite its promising characteristics score the rarity of Earth and the delicate balance required to sustain life. Ultimately, the Crimson Refuge represents humanity's enduring quest to explore, understand, and converse. Each new disc closer to answering an dusklit its faint corner remind the vast emptiness of space. There are worlds waiting to be uncovered, worlds that may one what it means to be human. The Crimson Cradle, endlessly orbiting its faint red star, symbolize most profound questions about the cosmos. Here, this stellar counterpart grows less mysterious yet increasingly fascinating. As more data trickle, telescopes and missions, Twilight Enigma become possibilities, a world that offers both tantalizing clues and about the nature of life and planet. The alien beacon, forever cautional lock with its hook, has long been the subject in speculation. Unlike Earth, where global weather systems are driven by the rotation of the planet, this dusklit sphere presents a more static yet equally complex challenge. Scientists believe that winds on the planet and moisture from its dark hemisphere, creating systems and atmospheric jets twilight zone. Dynamic, known as atmospheric redistribution, a crescent of habitability wider than initially believed, providing an even greater chance for liquid water and life to thrive. What truly sets the shadowed sibling apart is its position within the TRAPPIST-1 system, a compact arrangement of 7 Earth planets. Each of these worlds orbits its ultra-cool red dwarf star closer than Mercury does to the Sun, yet their unique gravitational resonance stabilizes the system over also control forces acting on the reddish generating internal heat that might fuel volcanic activity or subsurface oceans. The delicate gravitational dance among these planets paints a picture of a system in harmony, each world influencing the others are only beginning to understand. On the surface, strange. Imagine a landscape where glows under a dim, stars constant. Meanwhile, the nights into infinite darkness, a frozen wasteland where temperatures could plummet to hundreds of degrees below zero. Yet, along where day and night be a zone of relative, a place of perpetual, where temperatures hover around the melting point of water. Here, life might find its foothold, pools of liquid water or layers of soil. Life exists here, it might look nothing like what we see on Earth. Under the dim red light of its star, photosynthetic organisms, if they exist, would need to adapt to the infrared spectrum, possibly appearing black or dark gray to maximize energy absorption. Alternatively, life could exist underground, shielded from radiation and thriving vents or within mineral-rich water reservoirs. Microbial life, similar to extremophiles on Earth, could be perfectly adapted to these harsh and alien conditions, surviving in environments that would be lethal to most terrestrial organisms. stellar neighbor is also a treasure trove for planetary chemistry. Its atmosphere, if it exists, holds the key to understanding its potential for life. Scientists' biosignatures, gas, methane, or nitrous oxide, that would indicate biological processes. However, even the absence of such gas has crucial information about its history, geology, and interactions with its parent star. The twilight enigma is a candidate for life, but a window into the diversity of planetary atmospheres in our search for habitable worlds across the galaxy. The tidal wonder poses a fascinating conundrum about water. What on its surface would be an indicator of habitability, the possibility of subsurface oceans cannot be ignored. On Earth, similar oceans beneath the icy crusts of Europa and Enceladus teem with the chemical ingredients necessary for life. The exo-Earth might harbor vast reservoirs of water beneath its rocky surface, kept liquid by tidal and geothermal heating. These hidden oceans, if they exist, could serve as cradles for alien ecosystems, protected from the harsh radiation of its red dwarf star. From a technological standpoint, the reddish mirror represents an extraordinary challenge. Observing a planet in faint requires unparalleled precision. The James Webb Space Telescope has already begun to reveal the first glimpses of its atmosphere, generation of observers even more. Missions like the Extremely Large Telescope, ELT, and the Habitable Worlds Observatory will bring us closer to answering the ultimate question: is this crimson world a home for life? Philosophically, the alien twist to confront our assumptions about what it means to be constitutes a habitable planet. If this world, with its extreme conditions and faint sunlight, can sustain would redefine our understanding of biology. Conversely, if it is barren despite its favorable characteristics, it might suggest that life is far rarer than we currently believe. Either way, the shadowed pearl serves as a mirror for humanity, reflecting both our hopes and our limitations for meaning in the universe. Exo-sibling is more than just a scientific target, symbol of exploration and ambition. Discovery has already reshaped our understanding of systems, proving that Earth-like worlds can exist in a wide variety of environments. As humanity continues its quest and beacon, we are reminded of the vast potential of the cosmos, the endless possibilities waiting just beyond our. This twilight cinched on the edge of possibility, the frontier of human knowledge. Whether or stands cosmic isolation, this will forever remain a testament to humanity's unyielding desire to explore, to dream. The Crimson Bastion, as it has come to be known among researchers, occupies a unique place in our collective imagination. Orbiting in the tranquil glow of its ancient star, this alien ember of what could be teetering potential. With its delicate balance of extremes, searing heat on one side, freezing on the other, it symbolizes resilient cosmic adversity. Yet it also serves as a mirror, deepest questions about life, and the fragility of existence. The twilight is part of a planet so densely packed as conventional wisdom its form and evolve. The TRAPPIST itself is a 7 Earth-sized world clustered around a star so that it barely is a star by traditional standards. These planets, including the dusklit wonder, are lost orbital resonance, a celestial dance that ensures their long-term stability. This arrangement defies the chaos typically associated with young planetary systems and raises questions about how such a finely tuned system could emerge. For the tidally frozen sibling, this resonance is a stabilizing force, but also a source of energy. The gravitational pull of its neighboring planets creates that heat its interior, much like Jupiter's moon Io. This could drive gravity on a scale Earth. These volcanoes might spew gases into the atmosphere, replenishing it with carbon dioxide, water vapor, molecules, sustaining a dynamic climate for billions of years. In this way, the exo-Earth might transform what appears to be a static, barren world into a planet teeming with geological activity. The shadowed twin also provides a rare opportunity to study the interplanet's atmosphere and its host star. Red dwarfs like are notoriously emitting bursts of radiation that could strip away a planet's atmosphere over time. Yet, the Crimson Sphere seems to have defied this fate, potentially thanks to a strong magnetic field. If confirmed, this protective field would suggest even planets orbiting volatile stars can retain their atmospheres and remain habitable, a finding that could dramatically expand the number of worlds considered capable of supporting life. In the eternal twilight zone, where the day side transitions into night, conditions may be just right for life. Here, temperatures are mild enough to allow liquid water to pool on the surface, while the constant dim light from the star might basic photosynthesis. The chemical interactions in this region could create a complex prebiotic soup, setting the stage for the first self-replicating molecules. If life's alien refuge, it might resemble Earth's organisms that thrive in environments once thought uninhabitable. From radiation-resistant microbes to chemical-eating bacteria, the possibilities for alien life are as varied as the conditions on this cosmic haven. The reddish cradle also inspires speculation. What on this alien? On the day some might see a dim, crimson sky dominated by the faint disk of the star, casting long, eerie shadows. The terrain could be rugged and rocky, punctuated by rivers of molten lava or vast plains of hardened basalt. On the night side, the darkness would be absolute, broken only by the faint glow of auroras caused by charged particles interacting with the planet's magnetic field. And along the terminator, where light and dark meet, the view might be otherworldly, a sky that fades from deep black to a dusky red, over landscapes softened by perpetual twilight. The exocompanion is more than just a geological marvel. It is also a testbed for humanity's growing technological prowess. Instruments like the James Webb Space Telescope are already probing its atmosphere for signs of life, searching for gases that could reveal biological activity. These efforts are pushing of what is scientifically possible, requiring astronomers to distinguish between natural processes and potential biosignatures. For example, oxygen in the atmosphere might result from water molecules broken apart by stellar radiation rather than photosynthesis. Such findings force researchers to reconsider what signs of life might look like on worlds vastly different from Earth. The twilight gem is also shaping the future of space exploration. Concepts for reaching nearby star systems, such as laser-driven probes, are being designed with planets like this in mind. These tiny spacecraft, traveling at a fraction of the speed of light, could reach the TRAPPIST-1 system in a few decades, sending back invaluable data about the Crimson Haven. Such missions represent humanity's first steps toward interstellar exploration, turning what was once science fiction. Philosophically, the stellar twin is a source of endless. It encourages us to think beyond Earth-centric definitions of life and habitability. If life exists on this dusk-lit sphere, it would force us to confront the idea that biology might be a universal phenomenon, emerging wherever the conditions allow. On the other hand, if it is favorable conditions, the rareness of our own planet, a fragile oasis in a vast and uncaring universe. As humanity continues to study the alien ember, its mysteries become part of our shared story. It is not just a scientific object but a symbol of what we can achieve when curiosity and ambition drive us forward. Whether it is life or a barren rock, the reddish sanctuary reminds us of the endless possibilities that lie beyond the boundaries of our solar system. It is a testament to the resilience of worlds, the creativity of science, and the unyielding desire to explore. The Crimson Frontier, perched in the quiet depths of the TRAPPIST-1 system, continues to captivate scientists, dreamers, and visionaries alike. This alien threshold is more than a distant planet, it is a symbol of discovery, a testament to the vastness of the universe and the potential for life. As humanity gazes at this dusk-lit sanctuary, it becomes a understanding how life might arise, evolve, under conditions unlike anything we have known. The stellar sibling, locked in its gravitational embrace, ancient star, is both a riddle and a revelation. Its perpetual day and night sides create a world of extremes, searing heat and separated by the tenuous balance of the twilight zone. Along this eternal dusk belt, where light and darkness meet, lies the greatest hope for habitability. The temperatures, stretching across the planet's surface, might harbor liquid water, the cornerstone of life. Here, under the dim red star, could exist ecosystems unlike anything humanity has ever encountered. The challenges are assumptions about thrive. The star it orbits, though faint and cool compared to the Sun, emits powerful bursts of energy in the form of stellar flares. These flares, while potentially harmful, might also serve as a catalyst for prebiotic chemistry in the planet's atmosphere, driving the formation of complex organic molecules. If life exists on this twilight refuge, it may have adapted to these bursts of radiation, developing biochemistries that use the evil ways. Such life forms might thrive in subterranean habitats or within protective layers of water, shielded from the harsh environment above. The surface of the Crimson Marvel might tell a story of resilience. Its rocky crust, shaped by billions of years of geology, could bear the scars of past or the evidence of ongoing volcanism. Tectonic forces, heating, might have created towering mountains, vast lava plains, or even deep fissures where geothermal activity provides a constant source of heat and nutrients. Geothermal hotspots, havens for life, much like hydrothermal vents in Earth's oceans. The potential for such environments makes the reddish oasis a prime candidate for exploration. Beneath the surface of the tidal wonder, there may be hidden worlds of water. Oceans, its core, could remain liquid for billions of years, creating stable environments where life could flourish. These oceans, shielded from the radiating dwarf star, might host ecosystems teeming with microbial life. If the exo-Earth harbors such hidden reservoirs, it would open new pathways for understanding how life might survive in the most unexpected. The dusk-lit sphere also raises profound questions about atmospheric chemistry. Atmosphere, if it could be a delicate balance of gases shaped by volcanic activity, stellar radiation, and potential biological processes. Scientists are searching for biosignatures, gases like oxygen, methane, and ozone, that could signal the life. However, even the absence of these gases would not mean the place, it could simply if they're familiar to us. In Cradle expand our definition of habitability and reconsider what life might look like on distant worlds. The shadowed cusp will become for cutting-edge technologies. The James telescope limits of what can be observed from such vast distances, providing insights into the planet's atmospheric composition, and even surface properties. Future observatories, equipped with even more advanced instruments, will allow scientists to map the surface of the stellar neighbor, detect weather patterns, and search for the faint glimmer that might indicate reflective ice. The age is more than a scientific curiosity, it is a philosophical challenge. Exists there, it would suggest leading to biology are occurring wherever conditions. Such a discovery would transform our understanding of the universe, that Earth is not unique, but part of a vast network of life. Conversely, twin proves barren, a rarity and preciousness of life on Earth, reminding us of the need to protect our fragile planet. The cultural impact of the reddish beacon cannot be overstated. It has inspired countless works of art, literature, and music, each exploring what it means for humanity to share the cosmos with other worlds. It has sparked debates about exploration, ethics, and stability as stewards of both Earth and the universe. For many, the stellar echo represents hope, a reminder that the universe is vast and full of possibilities, waiting for us to reach out and discover them. Exosibling also fuels dream travel. Apps like sails, fusion-powered spacecraft, and even wormhole travel are being developed with worlds like this in mind. One day, humanity may send probes or even crewed missions to this twilight, turning speculation into reality. Such missions would mark the beginning of a new era in exploration, one where the boundaries of our solar system no longer constrain us. The Crimson Sanctuary, whether it stands as a barren rock, is a testament to humanity's curiosity and determination. It is a reminder that the universe is vast, filled with worlds yet to be explored, each one holding the shape our understanding of existence. As scientists continue to study this cosmic mirror, they bring us closer to answering the age-old question, are we alone in the universe? The twilight enigma, forever circling its dim, is not merely a subject but a vessel for humanity's greatest ambitions and deepest inquiries. It serves as a bridge between the known and the unknown, a point of convergence for science, philosophy, boundless potential of human imagination. Each new discovery about this crimson mystery propels us closer to understanding not only its nature, but also the fundamental workings of life itself. The alien cradle, nestled in the of its star's habitable zone, is a reminder of the diversity of planetary systems. Unlike